Alright, so I thought I would make this video. You said that you had a couple issues following this. I said, how far did you get? You tried converting a sprite sheet into usable sprites, but you're not sure if the sheet has to be formatted a certain way. So pretty much I thought I would go over how a couple different engines format their sprite sheets and what that means for you as an end user. So here's an example of a sprite sheet. I just grabbed this from OpenGameArt. This is the free RPG asset pack by Bilowmaster. Um, has some sprites, blah, 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 nothing fancy. So for example, this is a sprite sheet. Now, each sprite sheet is going to do different things differently. It's going to depend on that person's particular use case as to how they're going to format sprites. Um, some engines care about that stuff. Most engines don't. Uh, so, for example, if we preview this one, this sprite, you'll notice that the top row is always walking down. The second row is always walking left, third right, last one up. So the reason for that is because that's how RPG Maker does their tiles, their sprites. So their sprites work that way, and the reason being that the engine changes which way they're facing. So because of that, you can have stuff where, like, in the engine, you can have movement routes. So you can say, okay, this event will turn up or turn left or turn right, turn down, move, all those different things. But Unreal doesn't really work that way. Um, so that means that that's something that, because different people are going to use Unreal for different things, that's going to change our use case. Uh, so as an example, I thought I would show how this particular sprite sheet here is formatted and what that means. So pretty much because of how RPG Maker works, in RPG Maker, if you have something like a door, you're pretty much going to be saying, okay, look, down, left, right, then up. And that will be how you get this animation to play. Because each of these frames that represents a different state will, they're a different frame in the animation. So here's an example. I just put this into a sprite and then formatted it so that, you can see this. And then if we hit play, you'll notice, okay, that plays. And then you could play it in reverse to, close it. Not a big deal. Pretty simple stuff as far as that goes. Now, in Unreal, pretty much what's going to happen is you would drag a tile set in. So with this tile set, what I generally like to do is figure out what the recommended size is. This guy actually goes ahead and says, this is original size 16 by 16, compatible with any engine. VxAce, asset double size for RPG Maker VxAce. That's because VxAce uses 32 by 32 pixel size. MV uses 48 by 48. And this is stuff that you can do manually, but a lot of times content creators will just do that because it takes no time at all. But that doesn't actually matter for Unreal. Unreal doesn't really care. So if we drag this in, let's just create a new folder here, and we will call this example. We'll go in here and we drag this in. When you drag this in, Unreal is going to treat it as a texture. So what we need to do is, if we preview this now, you're going to notice it's all blurry and crappy. And the reason for this is that most of the time textures are blurred. They're intended to be blurred by a 3D engine. They are made with the intention that they will be blurred. But because of the fact that this is pixel art, we don't want that to happen. So we're going to hit Apply Paper 2D Texture Settings under Sprite Actions. And then when we go in, they're nice and crisp now. So then what we can do is we can hit Extract Sprites. And what this is going to do is it's going to try its hardest to kind of like automatically figure out what sprites are what, but it's really bad at it. So we're going to go down to grid for sprite extract mode, and then we're going to manually define the size here. Because we know from this that it's 16 by 16, we can just type in 16 and 16, and this is going to rip all of these out into individual sprites. Now, you could even go a little bit further and say, you know what, I only want to extract, let's see, 3, 6, 12 sprites on the x-axis, but I only want to go down 4. So that would say, okay, we're actually just going to extract these, but not this. And this would be like, okay, so a margin. So sometimes you might have a sprite sheet that your artist took it and they like took the whole damn thing and just moved it over arbitrarily, probably for whatever workflow they're using. So if that's the case, then you would pop that in, but most of the time it's pretty easy to use something like Aseprite or GIMP, which is free to automatically fix that, or not automatically fix that, but manually fix that. If you have a background color, sometimes your assets will come with a background color. You can, do stuff like that. Or if you want to see how they work, like you can do that as well. Not a big deal. Super easy. So then we just click extract and then boom, all of our sprites are here. So this is going to give us all these sprites. Now, typically, I don't know how other engines do this. I know that RPG Maker uses an Atlas system for sprites. So pretty much what it will do is that instead of you referencing an individual sprite, what it will do is it will reference, like, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So like then you would have to manually plug in somewhere that you want to use sprite 1, 2, 3, and then like 13, 14, 15, so on and so forth for each character. And sometimes, you build the Atlas system so it is smart enough to know, blah, 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 who cares? We don't have to do that. Paper 2D, which is the 2D environment that Unreal has, lets us just pick a bunch like this. We can do that, hit create flipbook, boom. That's it. We got it. So we can actually pretty much, a flipbook is what it sounds like. It is you flipping through these animations quickly like this. So it's the idea of you literally, like if you've ever held an actual book, like those art books that you used to get with crayons as a kid, and then like you'd flip through it and it would play a little movie or whatever. That's all it is. That's the idea here, is that you're using that. And then you could use this and say, you could rename this and say chicken down walk. And then that would be, you could then just use that instead as a reference. So, and because it plays so fast, we could go ahead and say, okay, we're going to make this a bit longer. And now this feels better. You don't have to do it this way. There's multiple ways that you can do stuff like this. You can use frames per second up here. You can change the material, which I'm not going to get into here, but stuff like that. It's pretty easy. As far as Unreal matters, you don't really have to worry a great deal about a proper way of importing sprites, because it's going to come down to what you want to accomplish. If you want to make something where you tried recreating the 2D movement of a Pokemon or Zelda game, then pretty much all you need is the ability to move and the ability to update that animation. And so there's a lot of stuff here, but this is, pretty much all my player code. So like there's a lot of stuff that you don't need to even worry about right now. So pretty much if we just talk about our movement, um, what we can do is we can come into project settings, wait for this to load, takes 800 years, go down to input, and you'll see that these are our action mappings. And pretty much all this is this is like action 1, action 2, pause, menu up, menu down, menu left, menu right, left right axis, up down axis. So what we can do is if you create something in here that is a input event, then you can pull it up here. So for example, all this says is that if the left and right axis is being input via that input event that we just looked at and we bound to keys on our keyboard, if that's true, if that's been done and we can move, which is something that I have defined, then we're going to add movement input to our pawn, and that's our player character. The target is the self, and we're going to change the direction by -1 on the x-axis, and then we're going to scale that value by whatever this axis value is. So what that means is that an axis, as far as inputs go, generally goes between 1.0 and -1.0. So that means that if we open MS Paint here and just draw a line real quick, that if this right here is 1, wow, this is super thin, 1, holy cow, 1, and this is -1, then if it's 1 or if the number is positive, then we are moving to the left. If it's negative, then we're moving to the right. Now that's not necessarily what's happening in this particular instance. This is just an example. I know that, for example, like typically the way that numbers are drawn is like -1 and then 1, and then this would be 0. But I'm just using this as an example. It is a range. So it doesn't really matter what side is what. You just have to understand why it's working that way. So if 0 is no movement, aka nothing is being pressed, then any amount of press will result in a number. Now the reason why a lot of times you'll see something like an axis used is for joysticks, because with a typical button there are really just two states, pressed and unpressed. You are either pressing the button or you are not. With a joystick that's not really the case, because you could like press it a little bit, press it even more, or just fucking jack that thing all the way out there. And so because of that, there's going to be different values. Now additionally, then you also have to worry about dead zones. Real quick, a dead zone is just like sometimes controllers drift because of the hardware, so sometimes a dead zone is just a thing that's like there and it's in the center, and it means that if the input is not larger than, like, let's say 0.25, if it's less than 0.25, then we're just going to take it, chuck it in the dumpster. Otherwise, we might care about it. But so that's kind of why input events are set up that way. The video that covers that is actually Unreal Engine 4 Paper 2D. It's actually this one, this Blueprint Creating a 2D Side Scroller. This guy covers this pretty well in here. There's a point where he goes into, this is him kind of going over
sprites, and now
what we just went over with these sprites. He goes over flipbooks, all that, what that means. A little bit later, he goes over like how you import that into the engine. Goes over tile sets much the same way. It pretty much works exactly the same way. And then he goes over how this actually works. And with Unreal, all it really is if you're moving, then you're going to have an enumerator that you set based on what the input axis is. So if this is the x-axis, then you're also going to have a second axis that goes up and down. So this might be -1, and this might be +1. And so if that's the case, and you know that it's 1, 1, then okay, you're moving down and to the right. But if it's -1, -1, then you're moving up and to the left. So a lot of times that's what this sort of stuff does, is that you're just comparing these values and you're determining whether or not you're moving up, down, left, or right. And then you can like clamp values. So like for example, if you want to make it so that, okay, so for example, when I sprint, I want it to be that you'll notice when I start pressing down, it doesn't immediately change to the down animation. And the reason for that is because we're taking whatever value is larger. So in this instance, we're moving faster sideways than we are downwards. And that's why you get that kind of animation playing. I just pretty much take whatever the larger value is and toss it out. And then you can use a whole bunch of math like this to figure out a whole slew of crap. But it all stems down from you knowing, okay, these axes do something. So if this is not equal to 0, then you are moving to the left or right. And if it's not equal to up and down, you're not moving up and down. So if that's false, so these aren't equal, then you're gonna, do a whole bunch of stuff. If it is equal, you're gonna set the move direction to be whatever this is. You're gonna determine that, and blah, 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 blah. And then you can use that move direction. Like you can figure out what the direction is. Once you know that, you can set the right animation. Now I know that I just skimmed over that really quickly. So just to go over that, pretty much all movement is that you have an input axis event in your project settings. And that will take whatever input you have, let's say up, down, left, right. So for example, S is my down, that's -1. Down is -1. Up is 1. Up is 1. Same thing here. You'll notice that these add up. So all that means, if any of those buttons are pressed and I can move, and this has to do with other code, like if I'm swinging a sword, then I can't move. So if I can move, then I'm going to add movement that will be this value times this value. Then every frame I check this, and this will check if I'm interacting with something, like am I talking? If I'm talking with someone, then maybe don't do that. If I'm not talking with someone, but I can move, then I'm going to check if we have any directional input. So again, we're taking the input axis event that we just set up. We're making sure that it's not equal to 0. And then if it's just false, like nothing has changed, then we're just going to, set the flipbook based on this. Then if something has changed, we're going to update the last movement direction. And so we're going to take this axis, and this isn't presented in the most elegant manner. So what this actually does is it's going to start down here, and it's going to say, okay, is left or right axis greater than 0? If that's true, then we're going to the left. If it's false, then we check if it's less than 0. And if that's true, then we're moving to the right. But if that's false, then we're not moving left or right. So then it'll check here, and then based on the result of the up-down axis being greater than 0, it's going to move up if true, false if down. Now, that will then set this enumerator, and all this is 4 states, up, down, left, right. Once we have that, we can pass that over here. This will set a new flipbook based on some true or false things. So if the actor has any velocity and the length of their forward movement is greater than 0, they are moving. So if they're moving, we will play the appropriate walking animation. If they are not moving, we will play the appropriate idle animation. So that's why we set up this whole thing where we're checking the direction. You assign the direction, then you can play the animation based on that, and you just set the flipbook. So I would say take some time.
Setting them explicitly isn't that big of a deal.
Watch these videos. This specific one was really helpful for helping me wrap my head around it. This whole series is pretty good. I wouldn't watch it at speed 1, just set it to 1.5.
But as you can imagine, as we add, crouching and sliding and climbing and, shooting, all that other stuff,
a bunch of stuff really will kind of start to click. And if it doesn't, feel free to at me in here, and I'll see if I can help.